Ever wondered how a massive metal machine like a submarine can stay submerged for months without sinking? It's a question that piques the curiosity of many. Submarines, these titans of the deep, play crucial roles in various fields. The military uses them for stealth operations while scientists employ them for research, unraveling the secrets of the deep sea. Explorers too utilize these underwater vessels to venture into uncharted territories beneath the waves. Join us as we dive deep into the science of submarines. Submarines, as we know them today, have a rich history. It all started with the human desire to explore the deep, unknown spaces of our world's oceans. The first primitive designs were conceived as early as the 16th century, with inventors like William Bourne sketching ideas for underwater vessels. However, it wasn't until the late 18th century that submarines began to take a recognizable form, with American inventor David Bushnell's Turtle, the first documented submersible used in combat. The 20th century brought significant advancements with the advent of nuclear power. This technology gave birth to nuclear-powered submarines capable of staying underwater for months at a time. These modern marvels of engineering are a far cry from their early counterparts, boasting capabilities once thought impossible. Today, submarines play an integral role in marine exploration, military operations, and even scientific research. But how do these complex machines function underwater? The key to a submarine's operation lies in the principle of buoyancy. Now, what exactly is buoyancy? Well, it's the force that allows objects to float in a fluid, be it a ship on the sea or a helium balloon in the air. The principle of buoyancy states that the buoyant force acting on an object submerged in a fluid is equal to the weight of the fluid displaced by that object. This principle is the cornerstone of submarine operation. Submarines have special compartments known as ballast tanks that they can fill with water to increase their weight and decrease their overall buoyancy, allowing them to sink or dive. When the submarine needs to surface, it simply expels the water from these tanks and fills them with air, reducing its weight and increasing its buoyancy. But it's not just a matter of sink or swim. Submarines can also adjust their buoyancy to hover at a specific depth. They do this by adjusting the amount of water in their ballast tanks to achieve a state of neutral buoyancy, where the weight of the submarine is equal to the weight of the water it displaces. In this state, the submarine neither sinks nor rises but remains suspended at a specific depth. So how does a submarine dive and resurface? Well, to dive, the submarine opens valves known as flood ports to let seawater into the ballast tanks. As the tanks fill up, the submarine becomes heavier and begins to sink. To surface, the submarine uses high-pressure air to push the water out of the ballast tanks, making it lighter and causing it to rise. But what about the pressure? As the submarine dives deeper, the pressure of the water increases. Submarines are designed to withstand this pressure, with thick, strong hulls that can resist the crushing force of the deep sea. Controlling buoyancy is one thing, but how does a submarine move forward? Well, that's a question for the next scene. Stay tuned as we delve into the power of propulsion. Propelling a submarine underwater requires a unique approach. We're not just talking about floating or sinking here, but the ability to move forward, to navigate the depths of the ocean. So how does a submarine do it? Let's begin with the propellers, the driving force behind a submarine's movement. These are not your average ship propellers. They are specifically designed to work efficiently under high pressures and varying temperatures of the underwater world. As the propellers rotate, they create a pressure difference in the water. The higher pressure behind the propeller pushes the submarine forward, while the lower pressure in front pulls it along. It's similar to how an airplane propels itself in the sky, but adapted to the unique conditions of the ocean. But what powers these propellers? It's not like you can just fill up a gas tank and go. This is where nuclear power comes into play. Submarines are fitted with nuclear reactors that provide an almost limitless power supply. These reactors generate heat, which is used to create steam. The steam is then used to spin turbines, which in turn rotate the propellers. It's a neat, self-contained system that allows submarines to stay submerged for extended periods without the need to refuel. However, navigating the depths isn't just about propulsion. It's also about stealth. Submarines are designed to operate quietly to avoid detection. Every component, from the nuclear reactors to the propellers, is engineered to minimize noise. Even the hull of the submarine is lined with sound-absorbing materials. This quiet operation is crucial in military applications, where submarines need to move undetected. So there you have it. The power of propulsion in a submarine is a fascinating combination of physics, engineering, and strategic design. It's about harnessing the forces of nature to navigate an environment that is both challenging and mysterious. Now that we know how a submarine moves, how do the people inside survive? Let's dive into that in our next scene. Living inside a submarine is unlike any other human experience. Imagine spending weeks, perhaps even months, under the sea, surrounded by the deep blue with no sunlight, no fresh air, and limited space. It's a unique lifestyle that requires some of the most ingenious engineering solutions to make it possible and safe. Submarines are designed to be self-sustaining underwater habitats. This means that everything needed for human survival must be generated, stored, or treated within the confines of the vessel. Let's start with the air we breathe. The onboard oxygen generators separate the oxygen from seawater, creating breathable air and releasing the remaining hydrogen back into the sea. These systems also remove carbon dioxide, a byproduct of our respiration, ensuring the air inside remains fresh and safe. Next, let's consider food. With limited space and no access to fresh produce under the sea, food storage becomes an intricate puzzle. Meals are carefully planned and packed before the journey, with a focus on non-perishable items and foods that can be stored for long periods. Think canned goods, vacuum-sealed packets, and lots of instant coffee. As for waste management, it's another challenge altogether. Solid waste is compacted and stored on board until the submarine surfaces, while liquid waste is treated and purified before being released into the sea. But it's not just about survival. Submarines are also equipped with facilities for exercise, entertainment, and communication with the outside world. After all, the crew's mental well-being is just as crucial as their physical health. Living in a submarine is a testament to human resilience, adaptability, and the power of engineering. It pushes the boundaries of what's possible, turning the inhospitable depths of the ocean into a place where humans can not only survive, but thrive. Submarines are truly marvels of engineering. Every intricate detail, every system, every process is a testament to our ability to adapt and innovate in the face of challenges. It's a world under the world, a life beneath the waves. Submarines have a crucial role in our world today. These underwater vessels, once seen as mere curiosities, have become indispensable in a variety of fields. In the military realm, submarines are the silent guardians of our seas. They patrol the depths, providing a deterrent to potential threats and maintaining the balance of power. They are equipped with advanced technologies that allow them to undertake covert operations, gather intelligence, and carry out precise strikes when necessary. But submarines aren't just for warfare. They are also invaluable tools for scientific research and exploration. They allow us to venture into the deep sea, an environment that remains largely unexplored and holds untold secrets. Marine biologists use submarines to study the rich biodiversity of the ocean depths, while geologists utilize them to examine the seafloor and the Earth's crust. Furthermore, submarines play a pivotal role in undersea archaeology, helping to uncover shipwrecks and relics of the past. They offer us a window into history, revealing stories that were once lost to the ocean's depths. In the energy sector, submarines are used for laying and repairing underwater cables and pipelines, facilitating our global communications and energy networks. In the realm of space exploration, the principles of submarine technology are even being applied to design vehicles capable of exploring the oceans of other planets. Submarines are more than just underwater vessels. They are tools for discovery and protection. Today, we've explored the fascinating world of submarines. We've journeyed from the enigmatic depths of the ocean, where the need for submarines first arose, to the birth of these remarkable machines. We've delved into the science of submersion, understanding how submarines dive and resurface with grace and precision. Our journey continued with the power of propulsion, the force that propels these magnificent machines through the vast oceanic expanses. We've peeked into life inside a submarine, a unique existence shaped by the constraints of underwater travel. Lastly, we've discussed the critical roles submarines play today, from scientific research to defense. Each element of a submarine, from its design to its operation, is a testament to human ingenuity. The depth of our understanding mirrors the depths these machines traverse. Next time you hear about a submarine, Remember the science and engineering that make these incredible machines work. Until then, keep exploring.